Good day everyone, you are welcome to my YouTube channel once again. Today we have this algebraic problem that if alpha and beta are the roots of the equation x squared minus 2x plus 6 equals 0, then find the value of alpha raised to the power 15 plus beta raised to the power 15. Now in this question, we assume that this alpha and this beta are the roots of this equation. Okay, but the first thing that will come into my mind is to try and check if the roots of this equation are going to be real or if they are complex. Because some students, once they see this type of question, they will quickly just go and solve this quadratic equation. And when you get the roots of this quadratic equation, let's assume the roots are complex. It will be very difficult for you to evaluate this. But let's assume the roots are integers. Let's say real roots, integral real roots. So we have, let's say 2 and 3. We can easily evaluate 2 raised to the power 15 plus 3 raised to the power 15. But it will take a little bit time. Okay, now let's check whether the roots are real or complex. Now we're going to use the discriminant method, that if b squared minus 4ac is equal to 0, then the equation has 2 equal real roots. Then if b squared minus 4ac is less than 0, then the equation has 2 complex conjugate roots. If b squared minus 4ac is greater than 0, then the equation has 2 real distinct roots. So now, the general form of any quadratic equation is ax squared plus bx plus c equals 0. Okay, now, from this equation, x squared minus 2x plus 6 equals 0, our a is equal to 1. Our b is equal to negative 2. And our c is equal to 6. Okay, b squared is going to be negative 2 squared minus 4 times a, 1, times c, 6. So, minus 2 raised to the power 2 is 4, minus 4 times 1, 4 times 6, that is what? 24. So, 4 minus 24 is going to give us negative 20. And this is obviously less than 0. Therefore, the roots of this equation, they are going to be complex. Okay, but finding the roots of this equation is not going to help. So we're going to perform some algebraic manipulations here. Now, from Vitis formula, we all have this equation, general form of any quadratic equation, that if the roots x1 and x2, then x1 plus x2 is the same as minus b over a. Then x1 times x2 is what? C all over a. Okay. Now with the help of this, we're going to determine, without knowing the roots of this equation, we're going to determine their sum and also their products. So since alpha and beta are the roots of this equation, so we have alpha plus beta is equal to minus b over a, and minus b here is minus open bracket in the negative 2, which is what? 2 over a. That's the coefficient of x to the power 2, that is 1. So the sum of the roots equals 2. Then the product of the roots, that is alpha times beta, is going to be c over a, and this is 6 all over 1. This is equal to 6. Very good. Now, from this expression that we are about to evaluate, there are some algebraic properties we're going to observe first. Alpha raised to the power 3 plus beta raised to the power 3 is equal to alpha plus beta to the power 3 minus 3 times alpha times beta over against alpha plus beta. Then another property here is alpha raised to the power 2 plus beta raised to the power 2 is alpha plus beta raised to the power 2 minus 2 alpha times beta. Okay, now this expression, put it down here. Alpha raised to power 15 plus beta raised to power 15. You know, this is alpha, just indices more. Alpha raised to power 5 raised to power 3 plus beta raised to power 5 raised to power 3. Then, using this property here, I think we have alpha raised to power 5 plus beta raised to power 5 raised to power 3. Remember, this property here is what I'm using. Minus 3, alpha raised to power 5, beta raised to power 5, open brackets, alpha raised to power 5 plus beta raised to power 5. Very good. Now, from here, we are going to, I think from here, we are going to know the value of alpha raised to power 5 plus beta raised to power 5. Okay, determine the expansion of alpha raised to power 5, alpha raised to power 3 plus beta raised to power 3 and alpha squared plus beta squared. Now, alpha raised to power 3 times alpha raised to power 2 is alpha raised to power 5 plus alpha raised to power 3 times beta raised to power 2 is alpha raised to power 3 beta raised to power 2 plus beta raised to power 3 times alpha raised to power 2 is beta raised to power 3 alpha raised to power 2 plus beta raised to power 3 times beta squared is beta raised to power 5. From here, we're going to make alpha raised to power 5 plus beta raised to power 5 to be one side and the others, that is making it subject of formula. Let me just put it that way. Then we have alpha raised to power 5 plus beta raised to power 5 to be the expansion of this plus beta raised to power 5 alpha squared plus beta squared minus here alpha raised to power 3 beta raised to power 2 minus again beta raised to power 3 alpha squared. So this is what? Alpha raised to power 5 plus beta. This is alpha raised to power 3, alpha raised to power 3 plus beta raised to power 3 and alpha squared plus beta squared. Then minus, putting minus out of the bracket. So I think we're going to have minus alpha beta squared. Yes. Then alpha plus beta. Because if you try to use this to open the bracket, we'll still get this back. Okay. Now, our next step is to find the value of alpha raised to power 3 plus beta raised to power 3, which is going to be very simple. Since we know that alpha raised to power 3 plus beta raised to power 3 is equal to alpha plus beta raised to power 3 minus 3 alpha times beta, open brackets, alpha plus beta. So putting the value, alpha plus beta is 2. So we have 2 raised to power 3 minus 3 times alpha times beta. Alpha times beta is 6. So this becomes 3 times 6 times, that is the bracket, alpha plus beta, and that is 2. So, you know, this 2 raised to power 3 here is 8 minus 3 times 6 is 18. 3 times 6 here is 18. And 18 times 2 here is what? 36. And 8 minus 36 is giving us negative 28. So this is the value of alpha raised to power 3 plus beta raised to power 3. Then alpha squared plus beta squared is going to be alpha plus beta squared minus 2 times alpha times beta. Alpha plus beta squared means 2 squared minus 2 times alpha times beta, that is 6. Then we have 4 minus 12. This is giving us negative 8. Very good. Now we can easily compute the value of alpha raised to power 5 plus beta raised to the power 5. So we have alpha raised to power 5 plus beta raised to power 5 to be expansion of alpha raised to power 3 plus beta raised to power 3 and alpha raised to power 2 plus beta raised to power 2. And that is negative 28 times negative 8. Okay. Then minus alpha times beta squared means 6 squared times alpha plus beta, that is 2. So when you evaluate this carefully, this is giving us 152. Therefore, I think we're almost done with the question. So we have alpha raised to power 15 plus beta raised to power 15 to be, from this place, we have alpha raised to power 5 plus beta raised to power 5 to the power 3, meaning 152. That is the value of alpha raised to power 5 plus beta raised to power 5. raised to the power 3. Very good. Then minus 3. Alpha raised to the power 5 plus beta raised to the power 5 can be rewritten as alpha times beta raised to the power 5. So that becomes 3 times, alpha times beta is 6 raised to the power 5 times alpha raised to the power 5 plus beta raised to the power 5 is 152. When you use your calculator and evaluate this carefully, this is giving us what? Negative 34048. And this is the value of alpha raised to the power 15 plus beta raised to the power 15. This is what we call algebraic manipulation. And this works out very well manually. No need of calculating devices. Please, thank you for viewing and make sure you subscribe to my YouTube channel for next video.